Hi everyone, hope you enjoyed this week's video on using libraries when programming. First, let's ask ourselves, what is the purpose of libraries? Well, almost all programs reuse code that is already written. For example, when you're printing an integer in C0, you're reusing previously written code that turns an integer into a terminal output. And this is what libraries are for. They implement functions that may be useful across many applications. Perhaps more importantly, libraries promote abstraction, which is the process of ignoring irrelevant information to focus on what truly matters to us. In 122, abstraction gives us the ability to hide details that the user of a library, also known as a client, should not know about, like the implementation of specific functions. This promotes abstraction by letting us focus on what the library code does, not on how it does it. Think about the process of driving. When you learn to drive a car, you learn that stepping on the gas pedal makes the car accelerate, and turning the steering wheel makes the car go left or right. But you don't learn how the gears, the engine, or anything under the hood works. The car manufacturers have deliberately exposed only the functions that matter to you. Now, let's define some important terms: the library, interface, and implementation. The library is where the reusable code resides. The interface is a summary of the library functions that you, the client, are able to use. And the implementation of these functions is the code determining what the functions do. For any function, the interface focuses on what it does, while the implementation focuses on how it does it. Let's make distinctions between these concepts using our car analogy. The library is the car, the interface consists of what you can see and use within the car, and the implementation includes all the parts under the hood that allow these components to function. So how does this showcase the benefits of abstraction? Well, if you drive a different car, say you now drive an electric car instead of a gas car, you don't have to relearn how to drive the car. So whether a car is gas or electric, the pedals, the steering wheel, and everything else are used in the same way and achieve the same purpose. This represents the interface. However, what actually happens internally when you drive is different, and that represents the change in implementation. Here's another important question to ask: how do we enforce correctness? You guessed it, by using contracts. Contracts serve two main purposes here. One, they help the implementer write correct code, and two, they prevent the user from abusing the library. Implementation contracts should include data structure invariants, also known as representation invariants, to help the implementer obey their own implementation when coding. On the other hand, interface contracts prevent the user from providing invalid inputs, and also enforce valid outputs. Contracts are similar to warning messages in a car manual. For example, if the car manufacturer tells you not to drive with your feet or pee on the dashboard, it is for your safety while driving the car, since it's telling you to avoid improper usage of the car's parts. Note that these warnings shouldn't touch on anything beyond what the user can see, like how the engine is constructed. Similarly, we shouldn't include data structure invariants in the interface, so that the client does not see the underlying data structures used for each implementation. These invariants are like the diagnostic things that monitor the car internally, and therefore belong under the hood. Given this information, you may be wondering, what is the client allowed to do? Since the client is the person driving a specific car, they can only use the functions and other information given to them by the interface. This practice is called respecting the interface. In the context of driving, this is the same as only using the car's visible components to drive the car, rather than trying to move it by manipulating its inner workings. That seems pretty simple. Perhaps a better question is, what is the client not allowed to do? There's one main rule that all clients should follow. Do not disrespect the interface. In other words, car owners should not be meddling with components under the hood. Let's say a car owner knows how engines are started, so instead of using the key, he opens the hood and jump-starts it every time. This may eventually not work when the inner components change. Going back to our old example, if you were to do this with an electric car, you might make a fatal mistake. Therefore, you should always respect the interface, because not doing so will cause issues when implementations are altered. This reflects a very common mistake, which is assuming how something is implemented when writing an interface function. Here, the client assumes that the car runs on gas, which causes the underlined error at the bottom right, since the ignition field does not exist in the implementation for an electric car. Here's a fixed version of the client's code, since it's using the interface functions rather than directly modifying the underlying data structures. So, how does driving relate to 122? Hopefully, you now have a better idea of how libraries work, and what not to do when using them. Here are some final things to keep in mind. In 122, you'll be asked to write code from both the client and library perspectives. On the client side, just be sure to respect the interface. This is true even if you know the implementation. On the library side, you can manipulate data structures directly or use representation invariants for your own sanity, but recognize that doing so isn't necessarily required. In other words, all client-side functions are valid library-side functions, but not all library-side functions are valid client-side functions. Furthermore, one of the goals for having you write both client-side and library-side functions is so that you become more familiar with the process of separating your code into smaller parts, which is called modularization. In the end, we hope that this car analogy served as a nice vehicle for understanding how libraries work. So, thanks for watching, and happy coding!